Welcome back, folks. We're going to talk about the other components that we have available to us so far in this course, and that is voltage supplies and current supplies, and when we can combine those. We're going to start off by looking at voltage supplies. We can't always combine them. Resistors we can. Voltage supplies not so much. We can only combine them when they're in series. Okay, so if I take two voltage supplies, let's draw them like this. Let's get them on the screen for you too. There you go, two voltage supplies. And we draw them like this. They're going to share this node exclusively, so they're in series. Okay, and let's just stick a resistor out here for safekeeping. When they're in series, we can say, let's pick some numbers. This is going to be a 12 volt, and this is, oh, I just did math in my head without meaning to, a 6 volt. And when they're in series, we can combine them because we're looking at the difference in energy between the terminals. All right, so if I start here and, well, we could think of it as ground. I don't know. It's just it's the negative side of the supply. We don't need a ground necessarily. But if I move from here to here, I go up 6 volts, and I go up 6 volts because I'm moving from the low energy side of the supply to the higher energy side of the supply. So if I move from here to here, I go up 6 volts. If I move from here to here, I go up another 12. Okay, so I can redraw this, and I can say that this supply, since it's in series, okay, is 12 volts plus 6 volts, also known as 18 volts. Okay, so that 18 volts, whether it's created by these two individual supplies or it's created by this one equivalent supply, that 18 volts is seen across this resistor. If it was a 9 ohm resistor, the 9 ohm resistor would end up having 18 volts divided by 9 ohms using Ohm's law. 2 amps through that one and 2 amps through that one. So the resistor, the things connected to these supplies, they don't care whether we have a separate 12 volt and a 6 volt or the combined 18 volts in one shot. Okay, so we can combine them when they're in series. Can combine when in series. Don't do it when you're in parallel. Okay, can't combine, cannot combine when in parallel. Don't do it. Bad for you. Okay, and I want you to think about it a little bit. If I took two voltage supplies, and this is usually where I'd ask you to pick some numbers. Somebody would yell out pi just to drive me crazy. Okay, so let's say 48 volts and 5 volts. Why would you do this? You wouldn't is the answer. Okay, if you did this, those two supplies are in parallel. They're also in series. And when things are in parallel, they're supposed to have the same voltage. So we kind of broke one of the underlying assumptions that we use in circuit analysis, that things in parallel have the same voltage. And that's the, I guess, more theoretical, not really too theoretical, reason of why we can't combine voltage supplies in parallel. Now, if I were to do this in practice, you know, this is this wire in between is this nice, perfect, ideal wire with 0 ohms of resistance and 0 henries of inductance and all, you know, perfect wire, magical wire, doesn't exist in real life. What's really going to happen is we're going to get a little bit of resistance, okay, small resistance, okay, and I'm going to get 48 volts on this side, and I'm going to get 5 volts on that side, and we're going to get current flowing left to right, and we're going to get a lot of current because the resistance is small, and it's going to burn up the wire. It's going to burn up whatever components are in the voltage supplies. Something's going to go pop. So you generally don't want to do this with voltage supplies. Okay, so don't combine voltage supplies in parallel. Don't connect them in parallel. Okay, just bad practice all over. But we can do it in series. So let's look at a couple other examples of what happens when they are in series. Okay, polarity does matter. All right, so similar to our example that we started out with, let me get my polarities right based off my notes here. Okay, polarity does matter, so we can play the same game. These are still in series, but now this one's plus on top and this one's plus on the bottom. Okay, so let's call this 14 volts and 7 volts, and I think I called this 21 ohms, and we want to simplify this circuit. These are in series. We're good there. I go up 7 volts and I go down 14. So from this point up to this point, I've dropped 7 volts. Okay, so if I draw it this way, I started here, right? And I'm going to draw the negative side on the side that I started. I go up 7 and I go down 14. So this is going to be 7 minus 14 equals negative 7 volts. But this polarity has to match there. Okay, connect it back over here, and 21 ohms, and it looks to me like we're going to get negative 1/3, oops, weird 3, of an amp, and we would get that same thing over here. All right, if we wanted to flip the supply, if we wanted to draw the equivalent this way, I'll draw it a little smaller maybe, minus plus. Okay, if I wanted to draw it that way, then I should start here and work my way down. So I go up 14 and down 7. So that'd be 14 minus 7 equals 7 volts. Okay, so I flipped the plus and the minus, but I also flipped the sign, and it worked out, and we end up with the same thing. The current going in this direction, since it's going to flow from high to low potential, it's actually going to go up. It's going to go opposite that arrow, and it's going to be negative 1/3 amp still. Okay, so polarity matters. Make sure you're getting your polarities right. If they all match, it makes your life easy. You know, if everything is minus plus, minus plus, minus plus, it's easy. But when we get this mismatch, we have to consider what's going on. This is plus on top. This is plus on top. This is positive. This is positive. This is plus on the bottom, and that ends up being the negative one here. Okay, so polarity matters. What else we got for you? Okay. Ooh, things in series. Probably should have emphasized this when we talked about series, but let's do it now, right? Second best time to plant a tree. Okay, so let's look at this example, and also means I got to update my notes so I don't forget it next time. So let's look at this one. Okay, so when two things are in series with a third thing, such as these voltage supplies, this voltage supply is in series with this resistor, and this voltage supply is in series with this resistor. So I can consider these two voltage supplies in series. Okay, in series. 3 ohm, and I guess I left that as a 21 ohm, and a 16 volt, it's a 6, and an 8 volt. Okay, so that's in series with a 3 ohm, that's in series with a 3 ohm. If I put current in down here, there's no place for it to go. It has to go through the other supply. And because of that, we can say that they're effectively in series, even though they don't share a node exclusively. Okay, and it's a little wrinkle to being in series. So we can combine them. Okay, I can say minus plus, and I'm going to start here, and if I go across this one, it's going to be up 8 volts, and then I'm going to go up another 16. So it's going to be 8 plus 16 equals 24 volts. Okay, the 3 ohm here, it's still part of the circuit. It doesn't like magically disappear. It's just not part of the supply. We can swap it, and we can say this is 3 ohms. Oh, that's why I left it 21 ohms, right? Because if that's 24 volts, these are in series. They do share this node exclusively. 24 volts over 24 ohms gives me 1 amp. 1 amp. Whoops. There we go. Got to powder the head still. Okay, so we can combine them that way. All right. That's voltage supplies. We can only combine them in series. Next video, we're going to look at what we can do with current supplies. I'm going to leave that as a mystery, but I'm betting you can guess when we can combine them. It's not when they're in series, I'll tell you that much. So we'll look at some examples of that. Stay tuned and good luck.